So guys, I want to start off by, can anybody explain to me what the difference between surface area and volume are? Because we've done volume already. James?
The difference between surface area and volume is area is the amount of space that an object takes up, and volume is the amount of space you can fit inside of an object. Is that it?
There's some stuff going on there. Jack?
Well, what's the difference?
So volume is just length times width times height.
Okay.
And surface area, you have to do width times height, and then that for each 6 sides if you're doing a square.
So what I'm going to take from what you said is one is 2D and one is 3D. Okay? What's another way you can explain the difference? Cal?
Surface area. If you're doing like a square, you find like the area of that side, and you can multiply by 2 if you're doing a square to find the
Okay.
side.
Monica?
Surface area is the area of the surface of an
Yeah. So this is like the outsides. And this is like all the insides. Right? Volume is how much something can hold. Surface area would be like, remember we talked about that poop pig? And on the outside of that thing was wrapping paper? Wrapping paper is kind of like the surface area. If it never overlapped, it just perfectly covered the outside, that's surface area. All the inside, that's the volume. So they're two different things. Like everything, I want to show you how to memorize this so that you're not just memorizing it. We can memorize the equations by kind of understanding what they're doing. So let's look at a prism here. Okay? I can make that look a tad better. Here's a prism. So imagine this. If I wanted to find the surface area, I'm going to shade these two things in a little bit. I could take the two bases. Let's imagine taking those. Actually, I would take two different bases off. The bottom and the top. We could take those off and set them aside, right? So that's where we would get surface area. I can take care of the two bases with 2 times the bases. That's the top and the bottom. So we took those off. So now it's kind of like are you guys seeing that box without a bottom and top? So the next thing I like to imagine is, again, that 3D printer. And that 3D printer, to get that outside, it's called the lateral area. The first thing it would lay down is the outside like that, right? Are you guys seeing that? A 3D printer lay that down? And then it'd lay that down over and over and over, right? And it'd get taller, right? Just the outsides? Are you guys kind of envisioning that? So that's why we're going to add the perimeter of the base. So the perimeter of the base would just be like that 3D printer laying that down once, and then times the height. So that's going to lay it down over and over and over, and it's going to make the whole thing. I'm going to try a different color of the shading. It gets tough when we're talking. It's going to make this outside lateral area fill in, the outsides. Are you guys kind of seeing how that equation builds the box? So imagine again, you would take the top and bottom off. That's 2 times the area of the base. Then we've got that open lateral area, like this. If we print just the perimeter of that and multiply up, we get the 4 outside sides of that box. Are you guys kind of visualizing that? So this gives me the top and bottom. This gives me the four other sides on the outside for the 6 sides total. Now this equation, the capital B is area of the base. The capital P is perimeter of the base. And the height is the height of the figure, which would be the distance from base to base. That's what the height is, the distance from base to base, if we're talking prism and cylinder. So you can imagine the cylinder being the same, right? You got your 2 circular bases. So imagine we can take those 2 bases off, and to get that lateral curvy part, if we take the perimeter of a circle, also known as the
Circumference.
Yep. So I'm going to write that here. Circumference if circle. Circ if circle. So you take that circumference and multiply by the height. That'll give us that curvy lateral area. So the equation makes us have all the outsides. It's kind of cool. Another way you can look at the cylinder is the net would look kind of like this. So here's 1 base. Here's 2 bases. This is the circumference. This is the height. So the net can be pretty helpful as well. Yeah, Lauren.
So if you
pi d, yeah, diameter times 3.14. Cool. So are you guys kind of seeing how the equation builds it? Much easier than finding all the different sides and adding them up, I think, like you did in your warm-up. A lot of math is like that. We look for ways, this is called an algorithm or an equation. We look to make things more efficient sometimes in math. Quicker, more efficient if we have the option. So this is, if you get a prism or a cylinder, the first thing you'll write down is this equation every time, right? Okay, so let's look at pyramids and cones. Do you know where you guys can see pyramids and cones? Egypt and
Any street cones?
and so you can see pyramids in Egypt and you can see cones at that place at Breton Village D&W Quick Stop. I don't know the name of it. Any ice cream place, okay? Egypt ice cream place. I'm going to sneeze. So, I'm going to actually this time show you the equation and then I'm going to try to explain where it's coming. So, surface area is, there's one base. And so I'm going to explain these things as I draw and build the picture for you, okay? So, it's hard to draw because it's three-dimensional, but we're going to do a square pyramid to start here. All right, so here's my base. That's the easy part of the equation, right? The bottom base. It doesn't have to be on the bottom. In this case, it's going to be on the bottom. And then I need a vertex. Okay, this vertex goes to all four corners. Hey, that's not too bad, guys. That's not too bad. It's almost good. All right, so here's my base. Again, big B is area of base. It could be a lot of different things, right? It could be a triangle, pyramid, or a cone. If it's a cone, it's going to be a circle, right? And then here's how I remember this second part. And it's kind of tricky. So it's kind of based on a prism. And here's where I get it. So you'll notice the perimeter of the base again. Also, or it could be circumference too. And we're going to multiply by this. This L, that is called the slant height. And the slant height is actually this height right here. Along one of the triangular faces. This is the slant height. Before when we were doing volume, we were going right angle to the base, and that was called the height of the figure. The slant height goes along one of the triangular faces. Now you can imagine, if you open up your triangular faces, that would be the kind of the height of the whole thing if your triangular face was going straight up and down. Right? You can imagine that? Now, instead of having two bases, we have all of one base and none of another. So how do we find an average of two things? Divide by 2, right? That's why there's the 1/2. So it's kind of saying that it's the average from being the height from one base to none, right? That's why there's the half, because there's not the two bases. So it's kind of saying, well, my height's going to be the average with the slant height of the two, all the base and none of the base. James.
Can you put measurements on the pyramid so we can try and find the...
Yeah, we're going to practice some after we've got these. What's really cool is not tonight, but eventually, I could give you the height of the figure and you could find the slant height because you know how to use some special stuff with right triangles, right? Pythagorean theorem could be coming into play at some point, will it? Like if I know this is a square and I know this is 4, I would know that this distance here is 2. If I know that distance and the height, let's say the height was 10, I could do 2 squared plus 10 squared gets me that slant height square. Because there is a triangle right there. Could be cool someday. All right. So that is how we build a pyramid or cone. We have a base. Here's the base. And then we're going to do half the perimeter times the slant height. So the slant height in the cone is the slanty height. The height of a cone, which we're not using, is that right there. The perpendicular height from the vertex to a base. We're using slant height for surface area. All right, and a sphere.
What, so the slant height is just the height?
No, the height is vertex to base. The slant height goes along the face.
Wait, so it's both have the same equation?
Yeah. Remember how we did that for volume 2? We just Instead of, if the base changed, we changed the area equation for the base. So sphere is kind of cool. It's just 4 circles. Circles and spheres are cool. You only need the radius. You got everything. It's pretty cool.
How is it a circle though?
So let's practice a couple of these things. 1 person per table. Go get the homework out of the basket, please. All right, guys, let's look at number 3. Numero tres. So who can tell me what kind of figure I have here? Adam.
Rectangular prism.
I have a rectangular prism, so I'm using surface area, 2 bases, plus a perimeter of a base times a height. So I'm going to find my 2 bases first, and I'm going to choose to do top and bottom. Okay, the top and bottom. So that's going to be 2 times 6 times 6. That's going to be my 2 bases, my top and bottom. So those are covered. So in my head, I imagine removing those. Now I need to find that lateral surface area. So I'm going to take the perimeter of my base, 24, and multiply by the height of 3. So here's my 24, these 4 sides, right? And I'm going to multiply it by this height of 3. And that's going to give me just the outsides of this. Right, and that's how the equation kind of works. I already got my top and bottom, and then I just worked on getting the outsides. So my surface area is 72 plus 72. Is that right? 144?
Yeah.
What did I do with my paper?
What?
Without it working. Where'd my paper go? There it is. I got it. I'm not going too crazy. So, questions on that one? Yeah. Titus.
So how do you get 72 plus 72?
Well, 2 times 6 times 6 is 72, and 24 times 3 is 72. So I was just telling you the math I was doing in my head.
Yeah, but how do you get 2 times 6 times 6?
So, I've got 2 bases.
Yeah.
The bottom base is 6 times 6.
Oh, I just did.
All right, guys, now we're looking at number 7. This one looks crazy. So, my surface area is going... How many bases do I have on this? 1 base.
What shape is this?
Then half perimeter of the base times, not H, slant height.
It looks like a diamond.
So here's what I see. This is my base triangle right here. You guys see that? Maybe I better highlight it. That's not showing up there. That's my base I'm going to find. So surface area equals 1/2 times 3 times 2.6. That just gives me my very bottom triangle that I highlighted. All right? That's just giving that base. Then for those other 3 sides, I'm going to have plus 1/2. The perimeter of that base is 3, 3, and 3. So 9. And my slant height is right there, 2.2. So I just get everything in my equation before I worry about doing any computation. So right here, here's my triangle. And right here, here's my other 3 sides of triangles. This is the 1/2 perimeter of the base times the slant height. So then I just slap all that in my calculator. So seriously, my calculator, I type 0.5 times 3 times 2.6 plus 0.5 times 9 times 2.2. Beep, boop, beep, boop, 13.8 square yards. Now, I heard of someone asking, why is it square yards? Well, one thing we know is area is 2-dimensional. Also, in our equation, the only place that we only have yards times yards, right? Yards times yards, that's yards squared. Yards times yards, that's yards squared. When we did volume, we had yards times yards times yards, that's yards cubed. Okay, so that's why this 2-dimension, that's why we have yards squared for our units. I picked that one because it's kind of hard to see the 2 dimensions on the paper, right? All right, let's do a sphere. All right, let's look at number 1. Surface area is 4 circles. That's how I remember the sphere. So I just need the radius. So pi times 2 squared. So if you wanted an exact answer, we'd have 16 pi square meters. That's the exact answer. But we're going to do an estimate to the 10th because that's what the directions say to do. And who are we to argue with directions, you know? So, I get 15.2 square meters. The reason we have square meters is a radius of 2 times a radius of 2 is 4 square meters, right?
So you wouldn't put like the 50.24, just do 50.
No, the directions say nearest tenth, so that's what I do.
Alright, yeah.
I'm not going to argue with the directions, man. Maybe. All right, guys, let's get after it.